And this is what they want to talk about. I want to talk about uncertainty in urban environments. Uh, I'm a planner, I'm an architect, so basically I'm used to manage into the unknown. And for starting with that, first of all, we need to come to understand what a city is. That is basically what we are talking here. And for sure, it's like a weak problem. Many people here has been talking about this for years, uh, and it's like a well-known thing for decades. Basically, they are a result of top-down and bottom-up processes. Many competitive processes. They are very complex. Probably the most complex human creation, I would say. I'm sorry for people like me who plan naturally, they have the mission not to be master plan. I'm an architect, but I cannot, that's not the way. So when we order cities, when we envision them, usually we work with this type of images, like very ideal, very clean, very neat type of images. But when we get them, actually, we do something more similar to that, which is like full of inefficiencies, full of social stress. This happens every single year in LA for 20 years, so it's something like a recurrent thing that's happened. This massive traffic, and even as well, I was trained of that. I was shown that Brasilia, that as well, it appeared yesterday over here. It's like one of these finest examples of modern city super well plan. It's from last century, but history is not always actually houses the biggest favela in the country. So this is also the picture history what we consider in cities. And why you should care about that? For sure, because I'm an architect planner, but everybody should care about that because basically we are much more people, more than ever in the world, living more and more in cities, more than ever. And this is why basically my co-research, and it was one of my concerns when I was working at a designer, was how we can bring new approaches, new computational approaches, simulations for making better plan, for making better design, bringing together co-creation, participation, and as well like the complexity which is embedded in urban settings. I want to show you three examples that was part of my dissertation here at ETH of how we can personalize this type of modeling approaches, computational approaches into cities. So we can serve as a kind of like medium scale approach. For that, we launch to Barcelona. Probably everybody knows the river bridge of the city, this officer.com, where we have all these streets that currently are used for all type of uses. Is the river street for traffic, for pedestrian, for commerce. In the last years, they came with this idea of the super blocks. That is what many of you here probably now or trying to create these pockets of blocks for promoting active mobility, giving more green space to the city, and thus allocating part of the streets to the general purpose traffic, like the citywide traffic. And it's very interesting how the city has been trying to push the implementation of this class during the last decade. So they have many different iterations, many different approaches to implement this general plan, this general idea, and as well trying to integrate local knowledge, participation from local stakeholders into the processes. Which is always like open to questions like who is leading this process, who has authority, who is bringing the data, which are the conclusions, who is basically leading and which is the outcome of these processes. So basically, on one hand, as in any planning process, we have on one hand that we need to create convincing and understandable policies, strategies, plans, and on the other hand, we are trying to engage people, to engage diverse stakeholders into the process. This is where computation, simulation, probably can help. So in this example, very simple thing, we try to simulate traffic in the city using AM-based modeling. For that, luckily enough, we got access to diverse data, open source data, but as well governmental data from the national, regional, and local government in Barcelona. For being able to approach and to face this challenge of simulating the city, we follow two main features of the simulation. First of all, we follow a macro simulation approach, which is like simulating one-to-one all the interactions of the vehicles, if you are in this case, for me able to create from the bottom up all this diversity, richness of interactions that we face in cities, in traffic, and as well the other main feature of this simulation approach was covering a huge geographic scope, which is basically half of the province of Barcelona, more than 6 million, 2 million, depending on of streets per day, for being able to give room for the simulation to develop and to unfold all this complexity, give room to short distance, but as well long distance effects that we may expect in this kind of systems. Having these two approaches, on one hand, micro simulation on a very large geographic scope, we managed to build and calculate micro simulation and to evaluate that. As in machine learning, we use a different data set for evaluating the accuracy of the model. So basically what we use for generating is not the same data that we use for evaluating the model. And we evaluate them on different spatial and temporal scales of aggregation. It was quite good for the state of the art of the models. There is no, as well as somebody was mentioning, they said there is no right models, but at least this one was quite useful for our purposes. And then with that, now, when we got the model, now, and this was interesting part, like how we can use and how we can personalize that for planning. And for that, as well, we are basing many of our intuitions into planning based on intuition, but as well like on experience. But there are like some things which are undesired or unexpected, which is happening in cities. So just tag along with me. If we imagine like a path in between, or somebody was going to A to B, then between 2 points in the city, we have two paths. Usually, if they are congested, the usual approach to planning is like, hey, let's create like a new connection, let's create like a new infrastructure. But sometimes it happens that it is detrimental. It makes the whole system worse. This is quite well known. This is Bryce paradox. It was described like decades ago, initially in Germany. And we have been observing this thing in planning, in real urban planning, for decades in the cities around the world. But as well, we have been observing the opposite effect, which is like by reducing space, for example, to vehicles, we can improve the network performance, which is challenging to be able to anticipate these effects. And this is what precisely we were trying to use on these models. So basically, we developed like a bunch of A/B testing, like different alternative future cities, combining with plans of the city. So we're starting with existing Barcelona situation, and then different combinations of how we can close down the streets in the city. And then we evaluate them basically based on efficiency metrics, which is basically time and distance of the streets, but as well from the environmental point of view, which basically are emissions and fuel consumption. Based on that, we obtain some metrics comparing like the different situations. We have our baseline situation, which is a gray one, and then at least we found one combination that show lower mean values for these options, which belongs to this configuration, which actually uses like a very minimal, very minimalistic intervention. We are closing down less than 1% of the streets in the core part of the urban area. But actually, it led to 40% of a saving of time for trips, for shorter trips, and as well a reduction of food consumption and street by around 7%, according to our simulation, which seems to be trivial, but actually in the city of Barcelona, it's equivalent to the 20% of the social budget when we were transforming that to CO2 emission rights. That sounds more controversial, but by the time that this paper was published. So basically, based on that, we managed to simulate this very macro simulation of a very large urban area, and we were able to identify scenarios that are aligned with these counterintuitive situations. But as well, we can see these type of unexpected effects on a larger scale. As I was mentioning before, we are having increasingly more people in the world living more and more in cities. It's not for everyone. As well, we have new trends in working cultures that are leading as well to more office spaces, which are increasingly less used, let's say that. And as well, we have this housing gap, but not all over the world. So, as in the previous case, we were basically, if we understand this supply-demand understanding of transportation, we were affecting on the supply side, on the roads. As well, we can try to understand which is the generation of the demand of the traffic in this case. So, and how is it affected by land use changes in the city? In this case, particularly, how we can repurpose from offices into housing. And for that, basically, we need to see how we can model those flows. And for modeling these flows and how they are affected by the densification, we can try to see how those pairs can be modeled. And we can consider, we can assume that the flows in between 2 points, 2 given points, are based on some features, characteristics of the region and the destination, but as well on some kind of distance and differences in between multiple locations. For that, we have this data that we were already provided, and as well a bunch of open source data regarding features of different locations of the city. We have land use, social demographics, that as well some topological data for understanding how the different locations were related. And with that, we can start to fit a model with this data and develop the econometric models for modeling this growth. That's when initially was proposed this idea, I thought that it was much easier, but actually it's still like an open mathematical discussion to fix and to feed this type of matrices, of very sparse matrices. When we have these models, we can start to elaborate on a hypothesis on how land use changes may be affecting traffic. And even nobody cares about that. Real estate companies are really concerned about that. How you can make the most of the actual empty properties or not that much profitable properties in many cities. So this is one thing that if we don't care, somebody would care, and we will transform those buildings. And we were able to identify those areas we were subject to this transformation. And then to develop a prognosis analysis. So as well, we can assume that not all the offices or not all the vacant buildings should be converted in this new land use, but we can develop like Bayesian studies on different percentage ratios of transformation. As well, these models again, they are not right models, so we follow a pluralistic modeling approach, kind of similar to a sample model, but a bit different. Just comparing different approaches for modeling the interactions at the spatial level. And we identify for sure transforming offices into housing reduce traffic, except when you were transforming all the offices into housing, because we weren't destroying kind of like the mixed-use character of those cities, which if you are in Japan is one thing that has been intuitively known and promoted for decades. So now that being that says, we can anticipate, therefore, the interactions, urban interaction based on data, and as well the densification is not necessarily related to increase of traffic calls. But as well, we can explore this type of anti-intuitive and nodal effects in a much closer picture. We are trying to repurpose our streets to new situations. I've been experiencing both do delivery in Paris, like the one with school traffic, and now with bike store, like a radical change. As well, we are trying to engage people who are saying that with commissions, as I was showing in Barcelona, but as well through participatory approaches, voting mechanisms as we have here in Switzerland, and as well much more modern real-time interaction tools as we have, for example, in Taiwan. And as well, we need to reformulate constantly how we design or we conceive our streets based on new technologies for transportation, smart infrastructure, and autonomous cars, which are like coming all the time. So on one hand, we have this technical question, how people may be affected by this new design, but as well how they are affected by how we communicate them. Somebody was really raising until there was a Sandra lab about how we communicate these new strategies. And for that, actually, we came down to the city and we developed a VR experiment. We know a city is not a lab, so we cannot run like A/B testing as we wish. But actually, VR provides like a very good grounding for being able to develop alternative scenario and test them with a lot of realism. We, very simple thing, we ask people to cross the street, this virtual street, on different scenarios without being hit by a car. Actually, some people were hit by a car, but nobody was injured, as far as we know. And that was the experiment. Very simple through different scenarios. So we have quite a lot of participants. We hosted it here in a bunker, in one of these wonderful bunkers that we have in Switzerland. A few participants with this simple task, crossing the street. 3 different scenarios that they were randomized. A regular street that everybody may understand is sidewalks, crossing what? The black. a river crossing walk. Another one was dynamic pavement that actually was allocating right of ways in a dynamic way with changing situations. And then one with is a flat street curveless that we can imagine that is feasible with autonomous vehicles in the future. So based on that, we randomize that across all the participants were experiencing all these groups. And as well, now we did a communication intervention. We were showing different approaches to communicate in the different scenarios, the new scenarios, a sequential one in which each participant was exposed one by one to these different scenarios, and a prior one in which they were able to compare side by side simultaneously the three different interventions. We divided the cohort, the participants in between two groups, so neither one participant were experiencing one communication strategy or the other one, only just collect data. Different types of data, physiological data, behavioral data, and as well like self-report data is on surveys pre and post intervention. I will assume from that. Very briefly, what we got is that people don't choose efficiency. We are not home economicals. Actually, they prefer other things. So just trying to optimize the streets probably is not the right approach. And that's why as well communication is crucial, because we need to commit this diverse feedback from people. Basically, we were able to develop this VR sandbox for testing new planning special policies with people. And then we identified that communication is actually crucial, which more than the actual plan-year intervention that does well. Again, maybe not design is quite interesting that how you communicate your project is far more important, which is the content of the intervention. So just to recap, you can see that actually the three examples or the same kind of like approach. Contesting kind of like common sense or like common practice in urban planning and in situ making, closing down to street is contested. It has negative effects. We can develop like a model that actually show that other like counterintuitive effects in the way that we can plan those streets. But as well, we can see like densification, which is as well very contested because people, and here Zurich is like a huge problem about like adding, for example, new e-source and new levels in buildings. It's as well contested. We can develop a model that actually is telling us that sometimes it's not really causing more traffic. And as well, in a smaller scale, how people may be accepting these new scenarios, we can develop ways of actually convey a much more crowdsourced and diverse approach to this, which basically is what I was referring at the beginning. I'm covering the unconventional aspects of planning, the unintuitive outcomes of design, and the unexpected effects from our decision making. And which is important because now we are able to develop new frameworks for championing for facing this type of effects. We have now the urban digital twins that are still like much more promising. That's actually like a real thing. And new data representations that allows us to develop new ways of collecting data and encapsulating interactions in the city, in such a way that we can model them and we can inquire more things to the city using semantics or using relational bits. And this is important because, as we were saying, urban planning, city making is an extremely complex process with a lot of people involved, many different stakeholders. And it's increasingly complicated or more complex with more public-private partnerships. And I cannot as many calls as you want to private-public partnerships because they are increasingly regulated by algorithmic governance. That even we don't know which are those circuits or this type of the smart contracts that many of them are regulating. It can extend our visions of what is possible and which is preferable as an urban future. And as well, it can allow us to develop safe sandboxes for testing policies or for testing new ways of making cities in a safer way and in a participatory way. So just to summarize this presentation, simulations and models are powerful, are useful, but not because they can predict the future. I'm not interested in that part of the prediction because they can change the way we think about how things could be, which is basically the very original meaning of design, of architecture, of spatial practice. And computation enables us to face and to interact with this complexity in a different way, in much more powerful ways. And probably we fail or we are failing in planning our cities because this complexity is not encapsulated on this idealistic, very neat images, how we are, these renders are how we envision our cities. Complexity is not there. Now with the rise of new AI tools, actually they are very exotic and they are very powerful for generating new images of cities. And this is very dangerous actually, because it's still this complexity is not embedded here either. But now we can generate many of them in a much more powerful, efficient, quick way. It's not still there. However, we can now unfold these complex interactions in such a way that we can use approaches that they are not restricting, but actually endorse complexity, which is based on participation and local knowledge, self-determination, and endorsing the this open nature of city. Basically, doing more with less, transition to more social technical systems, and developing new urban theories that actually we are missing. Most of the urban theories that urban science that we are using are based in very old theories. And basically for being able to make literature. Thank you so much for your time now.